Here's problem 1017. Particles, mass of each 0.2 kilograms, are placed at the 40 centimeter and 1 centimeter marks of a meter stick of negligible mass. The rigid body is free to rotate about a frictionless pivot at the 0 centimeter end. The body is released from rest in the horizontal position. What is the initial angular acceleration of the body? Alright, so what do we have? We've got a meter stick that's free to pivot about the 0 centimeter end, and then at 0.4 meters we've got ourselves a mass, and so there will be m1g, that mass being 0.2 kilograms, and then at the 100 centimeter end we've got another mass. It's called m2, causing a force, m2g, to be exerted at that point, and of course that mass is also 0.2 kilograms. So about our pivot at the origin, we're going to have two torques equal to force times moment arm for these two masses. Alright, so we would say then that our net torque would be equal to the summation of every force multiplied by its moment arm about this axis. And in this case, that's going to be equal to force 1, moment arm 1, plus force 2, moment arm 2, which is going to be mass 1g times moment arm 1, plus mass 2g, moment arm 2. And in this case, that's going to be 0.2 times 9.8 times 0.4 meters, plus 0.2 times 9.8 times 1 meter about this axis, because our moment arms are our distance respectively from our axis of rotation. 0.4 here, 0.1 or 1 meter there. So we're going to end up with what? 2.744 Newton meters. That's the net torque on this meter stick about that axis. Okay, we know that net torque should equal moment of inertia times the angular acceleration, and we really want to think in terms of angular acceleration or torques, because that will give us angular acceleration. So that's how we should be thinking in terms of this problem. So if we can find the moment of inertia, we can find the angular acceleration. So that's our next step. Moment of inertia is the summation of every mass multiplied by its distance from the axis of rotation squared. So it's equal to m1 r1 squared plus m2 r2 squared. And in this case, that would be 0.2 times 0.4 squared plus 0.2 times 1 squared. So what is that? 0.232 kilogram meter squared. So that is our moment of inertia. Hence, if I take net torque equal to moment of inertia times angular acceleration, I'll have angular acceleration is equal to my net torque divided by the moment of inertia. And that's going to be 2.744 Newton meters divided by 0.232 kilogram meter squared. And that gives me 11.83 radians per second squared. Everything is in SI system, so I'm going to end up with radians per second squared. As my initial angular acceleration, I found it by using torques. 11.83 radians per second squared. Answer.